Alright, so we're going to look at transformations, but before we can do that, let's talk about the word congruent. It should be familiar by now. Congruent figures, they just have the same size and the same shape. So these rectangles here, these are congruent rectangles, right? They're the same size and they're also the same shape. They're both rectangles. So if we're looking at the first type of transformation is called a translation. Now, first of all, a transformation, all it means is that we're moving a figure without changing its size or shape. So you can see here this triangle was moved over here, and that's called a slide. And you can see translation has SL in it, just like slide. So we're going to remember it that way. But it doesn't have to slide to the right. It could slide down this way. It could slide to the left if we wanted to. So we could slide it down. Wherever we want to slide it is fine. As long as it stays in that same size and shape, and we don't turn it or anything like that, or flip it over, then we're okay. So this would be another example of a translation. So these are all translations of this original figure. They're all the same figure, though. They're all the same triangle, and they're all the same size of a triangle. The next transformation, the next example of a figure that moves without changing its shape or size, is a rotation. You can see I made the T's really big in rotation. That is a movement of a figure around a point, or more simply, a turn, and that's why I made those T's big. So if we had this little half circle here, and I'm going to make a couple of these. An example of a turn would be a 90-degree clockwise rotation. So I say clockwise, just think of a clock. This is going against the clock. This way is going with the clock, right? We go toward, 1 o'clock, 2 o'clock. This would be 3 o'clock. It's a 90-degree turn. A 180-degree turn would be like this, right? Whoops. We'd go this way, and once it's on its bottom, that's 180 degrees. So we went 90 degrees and then 180 degrees. And then if we keep up with this theme, we have a 270-degree turn, which that'll look something like that. So it'll almost look like a backwards D. Counterclockwise, by the way, 360 degrees, that would get you back to the original figure. So you can see here, this actually does not have rotational symmetry, this figure, because it doesn't get back to its original point before 360 degrees. So I'm going to just create a couple of more of these, and you'll get the idea of counterclockwise too. Counterclockwise just works against the clock. So if I took this figure right here, instead of going 90 degrees this way, whoops, if we start back at the beginning, sorry about that, we'd go 90 degrees this way, and that's counterclockwise. So you can see that it's different than the clockwise. This is actually the same thing if you look at over here at the 270-degree clockwise rotation. This next figure, again, 180 degrees. It's actually going to be, we're going to start this way and we're going to go this way, but we're going to end up the same place we ended up the first time when we did 180 degrees, and that's not unusual. That's the way. 180-degree clockwise or counterclockwise. Think about a clock. If you go 180 degrees, you're going to end up at 6 o'clock either way. So you'll get the same shape. And then 270 degrees counterclockwise. I want to take the original shape if I can. Move it over here. We go left 90, 180, and then finally, whoop, went a little too far. That would be 270 degrees. It looks just like the right 90 degree. So this was the original. Again, if we rotate it one more time, that would be 360 degrees, and we get back to that original shape. Again, these are all called rotations. Rotations has 2 T's, and a turn is the same thing as a rotation. We just keep something right on its point. Alright, the last transformation we're going to look at is a flip or a reflection. The big word for it is reflection. And a figure that flips over a line and creates a mirror image. So you can see here, my E is an example of a reflection. Okay, so that was just reflected over this vertical line right here. And we call that line the line of reflection.